Hey, good day. Just want to welcome you to the training that we have on this Ultra machine. I've been with Bosch for about 14 years now. They hired me back in 2010 to be a geothermal trainer. I'm a geothermal guy. I live in Western Oklahoma. I got geothermal in my house. So I really, truthfully, if you cut me, I probably bleed a little bit geothermal. But let me tell you something about this piece of equipment behind me. There has nothing been in the last couple of years that has excited me as much as this particular piece of machinery. The Ultra is the big daddy, if you don't mind. I had a guy helping me put this together, and he actually called it the mothership, but you can call it what you need to call it. But let me tell you about this particular machine. It is unlike our other IDS unit, the BOVA versus the BOVB, in that we now can have the opportunity to go down to 5 degrees Fahrenheit and be 100% capacity. This particular machine has a lot of characteristics that we've had with it. With the other product, we still have 3/8 liquid line running from 150 feet, separating the indoor and the outdoor unit. We're familiar with that. We're familiar with weighing in the refrigerant at 0.6. This is at 0.59. We're familiar with the 350 micron vacuum. This particular machine has the new refrigerant in it, 454B. That's the refrigerant that Bosch has decided to go with within their product. The 454B wants to have a deeper pressure, more pressure as far as when we're putting the refrigerant lines. The books earlier said 150 pounds of pressure. This one's 250 pounds of pressure, making sure that the integrity of the refrigerant lines are good. But here's the thing about this particular machine. You already noticed that this machine is higher, it's taller. It's still the 30 by 30, but it's a little bit taller than the other 5-ton IDS 2.0 unit. The reason that it's taller is I have a different fan blade, I have a different shroud, I have a cupped fan blade now, literally allowing me to have this air movement in the winter time that allows me to have a deeper, greater BTU value. The one other thing that is inside this machine that you cannot see right now is a base pan heater that allows me to have that heated pan so that when I go into defrost in the wintertime, I don't get iced up on the pan. I get the water, getting the water out of the unit onto a concrete pad or onto the ground. One of the things about this particular machine is that how do we get to that 5 degrees using same technology? Well, you can't. So with this particular compressor, different than the BOVA and the BOVB, in that the BOVA had a Mitsubishi compressor. That's what the M on the end of the model number was. The G represents that George Mary Charlie Charlie compressor. So here's the thing about this particular compressor. This is a vapor injected compressor. And what we're going to be doing is this little item, plate heat exchanger, is inside this machine. And when we're running in the heat mode at about 50 degrees, there's a solenoid valve that opens up. There is a E-valve that this refrigerant is going to run through, allowing me to have a deeper refrigeration process by cooling the refrigerant before it goes into the compressor. That is some of the logic that is going to change within this machine. We really can't see it, it just goes on. But it only happens below the 50 degree mark. As above the 50 degree mark, we're kind of running like the BOVA unit, the BOVB unit type scenario. This particular machine has a different board. This machine still 172 to 270 volts. This particular machine still has a board that takes a AC voltage and does the DC, reacts, takes that DC down, allowing that compressor to have a variated type frequency to it so we get the variated BTUs and capacity. One of the other things that we're going to have to look at as an installer is we've been used to running 4 wires to the condensing unit. Man, what a great idea of just having 4 wires to a condensing unit, not having to run 6 or 8 or whatever it may be. And we've always said in training classes that we do communicate, but we don't communicate through the wiring like other manufacturers do. We communicate it through the refrigeration process. We've changed that. So in the process of this machine, we have the capability of still communicating through the 4 wires. We have now an opportunity to do the same as we've done in the past. But we also have a different way of communication where we're using the BCC10 and we can communicate that away, having a little bit of what you would call it dehumidification scenario going on, a little bit of better latent heat removal. But we also have what is called now a cloud communication. So I would like Chris Penn from Portland, Oregon to come in and explain those types of communications to us. Hey, Chris.
Hey, Fred, how's it going? Thanks for having me.
You bet, sir.
So as Fred mentioned, we have three styles or three different types of communication. This particular machine, as Fred was talking about, it does actually come default in the communication mode. There's a couple of dip switches that we're going to talk about. This is both on the indoor and the outdoor that defaults it to that. And in fact, our default on those particular switches are going to be in the off position. But what I'd like to do is I kind of want to run through a little bit of the communication processes. And I'm going to start with logic A. Okay, we've got logic A, we got logic B, and we got logic C. And because it comes factory shipped in that communication mode, I want to start by saying we're going to communicate via that communication wire that we spoke about earlier. It's an M1, M2 communication. It's a black and red wire that the factory harness is tied to. Our communication wire would then tie to that factory harness, through this grommet here below, and we're going to go from indoor to outdoor. That again is an M1, M2 connection. That factory connection is also on the Ultra, and it too is also tying up here through a couple of colored wires, black and red, again being our M1, M2.
So how many wires is that communication wire now? Being the logic A?
Logic A is now, again, factory shipped with the 2-wire. It's the communication wire, the shielded cable. Manual recommends a shielded cable. Technically doesn't have to be, but highly recommended in case we have interference.
So just 2 wires?
Just 2 wires.
Wow, okay.
And that's how it's going to come right out of the box.
Okay.
So with that logic A, it's going to operate like this. We are air handler. We have the ability to set what we're going to call an auto fan speed. Okay, this auto fan speed is going to give us 4 fan speeds. So let's call it medium high, medium high, medium low, and low.
Okay.
And we're going to vary those 4 different fan speeds as we use what we're going to call the delta T between TES, which is an estimated set point.
Okay.
We're installing a generic thermostat in this case. Pictured here, we do have, and we'll talk about logic B here in a second, but logic A is going to be a generic thermostat.
Somebody else's
thermostat,
okay.
Like we're already used to.
I don't want to take the thermostat off the wall. I'm used to it, but
exactly.
I want this unit. Okay.
Exactly.
All right.
And we're still going to wire that thermostat to the air handler, just like we normally would.
Okay.
Okay. The communication in this case is only between the indoor and the outdoor. It's not from the thermostat. So regular thermostat down. Okay. So the logic built into this, we're going to use now. This air handler comes with a T1 sensor. Okay, that T1 sensor is located down here underneath, kind of up underneath the evaporator.
Okay.
We're going to sense return air temperature in a flexible duct, return air,
okay,
that could be 50 feet away. But yet, I don't know what the set point is inside the house.
The thermostat?
Correct.
Okay.
So we're going to use an estimated. So what's going to happen is we're going to use T1 upon shutdown of a cycle. We're going to select a number after X amount of time of off time.
Okay.
And that's going to be my indoor set point.
Wow.
An estimated set point. So now we're going to use an estimated set point between an actual T1 set point, or while it's running.
Okay.
We're going to use the differential there. And now we're going to have a coil target temperature with temperatures between 42 and about 53.
Okay.
And it's going to vary based on that delta. So if we have 10 degrees, Fred, let's say, to make up, as we approach set point, I'm going to go from high fan speed to medium high.
Look at that.
As I approach closer, I'm going to go to medium low. As I get closer to set point, I'm going to shut off on low fan speed as my compressor and fan motor slows down.
So now my fan motor gets to utilize those fan speeds that were in there rather than the old BVA just having 1 speed or 2 speeds.
Exactly.
Wow.
And that's what we did before. We just used 1 speed, right?
Wow.
We had a fixed coil target temperature of 46, 1 fan speed. We can select that at a dip switch and change that a little bit, right? But in this case, yes, we're going to vary fan now and vary compressor as we approach set point using the delta between TES, which is estimated set point, and actual T1.
Wow.
Wide range, 42 again to about 53.
Wow.
Target. And on the heating side, that's going to be about 98 to 112.
Okay.
Somewhere in that neighborhood.
Okay.
So we get to, you know, it's about 10, 12 degrees there to play with.
Wow.
What makes that more efficient, more effective, is that we're not just stuck at a target. We're actually matching the target and matching the load as the load inside changes.
Right.
Right?
Yeah. Yeah.
That's logic A.
Yeah.
Logic B. Same communicating wire, same M1, M2.
Okay.
Okay. Now we're using a BCC 110, and the 110 is being connected standard, just like a normal thermostat. Red, white, yellow, green, blue.
Okay.
Okay. Orange.
To the air handler.
To the air handler.
Okay.
Now, upon getting connected to the cloud, using the gateway and the antenna,
Okay.
we are going to send information from the outdoor to the indoor
Through the.
through the cloud
Oh yeah. Okay.
of the thermostat. Now, the thermostat's got to be connected to Wi-Fi also.
Okay.
Okay. When the thermostat connected to Wi-Fi, send information back to the outdoor unit, and then the wiring to the thermostat to the furnace is normal, not communicating. Okay. The information we're sending for logic B, instead of an estimated T1, it's going to be an actual. Instead of an estimated set point, it's going to be an actual set point.
Yep.
Actual set point instead of an estimated. Think about the estimated for a second. The estimated set point can vary
Right.
and may not be as accurate,
Right.
right? Having an actual set point and the differential between actual and the T1 sensor that was added is even going to precisely more control my load as my indoor and outdoor load change. And that target number isn't going to be the same. On the cooling side, 42 to about 54, and on the heating side, 98 to about 112.
Okay.
Okay? So real quick in summary, the difference between A and B is an estimated set point versus an actual set point. And that actual set point goes to the cloud, comes back to the antenna, the outdoor unit reads it, and we're going to modulate accordingly as the indoor load changes.
So in the process of getting to that set point, this air handler is going to see what's happening and be able to dial itself down in CFM, if you don't mind.
Exactly.
And while that dials itself down into BTU,
That's correct.
getting a longer run time.
That's correct.
Removing a little bit more latent heat.
That's correct.
Boom.
There you go.
We got some humidity going out.
Now, we have some dip switches in here to set this also. It does come, again, factory set for communicating. However, there's also an auto fan dip switch that would allow me to do either two-stage fan or that four-speed fan.
Okay.
But in order for that technology to work, that logic to work, it must be connected in auto fan speed.
Ah, okay.
Okay.
So there's some things to manipulate in here. Read the IOM.
A little bit of commissioning.
Okay.
A little bit of commissioning. Some dip switch changes. Again, we're talking about communicating default. We're talking about dip switch SW7-1. That is going to be in the off position on the air handler. The switch used in the outdoor unit is going to be outdoor dip switch SW5-4.
Okay.
And again, those are going to be in the off position.
Okay.
Now, let's just say I don't have a BCC 110. I got a customer that don't care, or I don't want to modulate as much. Now I'm going to go to Logic C. Okay. Logic C is going to be this. These two air handler, or these two harnesses, I've got a white plug that comes with the outdoor unit.
Okay.
I got the black plug that comes with the indoor air handler.
Okay.
Okay. These two harnesses are going to come in the goodie bags.
We don't throw those away.
We should not throw these away.
Okay. All right. All right.
Anything that comes in the goodie bag.
Okay. There you go. Okay.
So when we get these, and we do want to go with just generic logic, I got to hook this to the air handler, hook this to the outdoor unit, and I'm going to run my regular thermostat.
Just like we've
done for 8 years.
Yeah. Oh, awesome.
8, 9 years.
Okay. Okay.
Now, there's some other caveats to that. If I do this, I got to flip those dip switches to non-communicating mode.
Ah, there you go.
Okay. So I can't connect both harnesses on both ends and not flip the switch. Otherwise, you're going to damage this control.
Okay.
We don't want to damage this control. Very, very expensive control, right? So if we're going to use these, and we're going to go with Logic C, and by the way, Logic C now is a fixed target coil of 48 degrees. On the cooling side. On the heating side, it's 108.
Okay.
About 108, 107.6,
Yep.
somewhere in there.
Yep.
Okay. Now, we have the ability with dip switches to bring those targets down.
Like we've done in the past?
Like we've done in the past.
Okay.
4 degrees down.
Okay.
We've got that natural drift, plus or minus 4, based on previous hour of operation. All that stuff's still there. But this is all provided, either A, I don't have a BCC, or the customer doesn't want one.
Or we don't have Wi-Fi.
Or we don't have Wi-Fi, because again, you have to have Wi-Fi in order for that communication to come back to this device.
Right, okay.
It's got to have Wi-Fi.
Wow.
Okay, so the key here is harnesses, field installed, not factory, and then you've got to flip the dip switch and make it a non-communicating product.
And we never want to do the 4-wire and the 2-wire together.
Not at the same time.
Okay.
It's right in the manual, big red circle, cross through it. Do not do it. It will damage your components.
Right.
Okay.
Wow.
Now, one other thing that's unique about the Ultra Air Handler 2, now that we've kind of gone over the logic a little bit, we kind of understand the logic. I know sometimes it's a little hard to grasp.
Right.
Especially when we've got this target and the 4 fan speeds and all that stuff. But the other thing about this guy too is we now have a strip heater kit for this that is 3-stage strip heater kit. Okay. And there's one more harness that comes in its goodie bag, and that's this little 3-pin to 4-pin adapter. Okay. The harness, or excuse me, the strip kits that come with this product, it's a 15i, 15 kW, and a 20 kW or a 20i strip kit. No harness necessary. Install your strip kit, put it in there,
let it go.
Set it accordingly. You're going to get 3 stages of heat there.
Wow.
Okay.
Wow.
Not including this. So technically 4 stages of heat, right? If I choose to use a 2-stage heater kit, which we now have a new UL listed EHK heat strip kits. Okay. 5, 7.5, 10, 15, 20, right? That's going to be a 3-pin. So I can install those kits in this product, but I need the adapter in order to do that. Plug and play.
Oh, that's awesome.
So the 2-stage 3-pin, the 3-stage 4-pin, and away we go.
Did you think of that?
I did not. This actually came in the
that's pretty good stuff right there.
Came in the goodie bag.
Yeah. What is real quickly? This is a 454B refrigerant. I see A2L everywhere and all that kind of thing. Tell us a little bit about the procedure of the A2L.
That's a really great question. A lot of some changes that we've added some sensors. You talked about plate heat exchanger earlier. Yep. So we've got parameters. We used to have 24 parameters, and now we're up to 42 parameters, right? On that. On that. And the reason we have that is because we added T1. We've added the plate heat exchanger, which has 3 sensors. Okay, we've got a T2 sensor, right? We have all these added sensors that's going to go into controlling this product.
You mean I can see what's going on in here out there?
Absolutely. In the communication mode.
Oh my gosh.
That T1 sensor, I can now read it on the board.
That's
that T2 sensor, I can now read it on the board.
Oh, that's awesome.
It's going to give me wattage usage of the indoor units as well.
Wow.
But yeah, and that's all part of that communication process.
Wow.
So I think there's about 4 or 6 parameters that are communication mode only parameters.
Wow.
Okay.
Wow.
But going back to the A2L part of it, we had to make some design changes on the board, from our previous air handlers. Okay. And those design changes with that R454B changeover was we had to change the fan motor. Okay? Right. We had to make it a sealed motor for flammability risk, because of the mildly flammable refrigerant. Yep. We also had to do some changes to the board. And part of those changes were adding a plug for the A2L sensor. Okay. Our A2L sensor is located right down here on the evaporator coil. Okay. This is actually in the upflow configuration. If we shift it to horizontal, left or right, or downflow, that's coil comes out, and we got to relocate that sensor. Okay. But what we're going to do, and the reason it ties to the board is, upon getting a leak, we're going to shut the compressor off, and we're going to turn the fan motor to high fan speed. Automatic.
That way we disperse the air that could be involved, or the refrigerant that could be mildly flammable, that is going to be now dispersed through the ductwork, so that it basically distinguishes itself.
We've got to dilute it. We've got to dilute it. We've got to have, there's our specific numbers and calculations that need to be done based on area served of the ductwork, right? So if I did sense a leak, I got to get rid of it somewhere. Right this second, I don't know what those numbers are, but again, there's some calculations that are going to get us there.
Wow.
And once we do that, In that case, if let's say we got a nuisance trip, it's going to shut itself off.
Okay.
And reset itself.
Okay.
In theory. Okay. It's not going to be a hard lockout.
Okay. And through the board, the condensing unit board, I will be able to see what's going on with the A2L sensor in here by going through a parameter.
There, again, the reason why we got 42 parameters, there's some other things that go along with that. Not only is there, let's say the sensor fails, just period, right? Just fails. We'll be able to see that on the board, right? But also, that is going to throw an error code and stored in that parameter,
Yep.
which is now changed to parameter number 3.
Okay.
It used to be, what, 22,
Yeah,
23?
exactly, yeah.
It's going to be parameter number 3 now, and we'll be able to go in there, and it's going to be a logged or stored code.
So if I walk up on the unit and the unit's not working, I can go down to that.
I would simply go to parameter number 3, right there. It's going to give me the last error code, which in this case is a B7, which was a refrigerant leak detection.
And it has really nothing to do with the condensing unit that's not working.
At this point, no. It sensed refrigerant in there.
Oh, wow. Okay.
Now, if we get low enough, we could see a low pressure switch.
Yep.
Trip, right?
Yep.
If we get low enough. But if it's, 1 ounce per 30 days or whatever that leak rate is, right? Maybe it trips once a month until it finally empties itself.
Wow.
But we're going to know it because that's why I'm bringing the fan speed to high.
Okay.
I'm going to let you know as a homeowner that something's wrong.
Yep.
I'm not running a normal fan speed.
Wow.
And then, of course, I don't got any heat coming out.
So again, all of this technology in a couple boxes, all of this technology is for this particular unit to literally be an ultra unit. Minus 13, 70% capacity at minus 13 Fahrenheit, 100% capacity at 5 degrees. Where I live, we may not ever see heat strips come on. Where you live, you may not need the 15, 20 kW of heat strips that you may have. But I will say, in all the years that I've been in this industry, and it's been a long time, by the way, this unit right here excites me today. And we really appreciate, Chris, and I really appreciate you sharing this video with you and yourself and others. And again, thank you very much.
Thank you.